Welcome to today's class. Today's class is vectors. We know in physical measurement we have scalar and vector. Scalar quantities are those quantities with magnitude but no direction. Example of those quantities, we have speed, we have energy, we have length. But under vectors, vectors are quantities that has both magnitude and direction. Example of vector quantities, we have force, we have velocity, we have displacement, we have momentum, and other ones. So, a vector is represented by a straight line of no magnitude or length drawn in a given direction. So we can say that this line now we see on the board is a vector. And is showing the direction of that particular vector where the vector is moving. The vector is moving from O to P. Now in this O to P, instead of us drawing this line, we can say that OP, we can use this to denote a vector, or we can use this to denote a vector. Now with this shows that this vector is coming from O and moving towards P. That is, it comes from O and goes towards P. That is what this vector is all about. So, for us to represent a vector in any alphabet, or we are using any alphabet to represent a vector, it must have a bar on top of its head, of any alphabet head, or an arrow showing where the vector is moving. If it is ordinary bar, it moves this way, but especially this one is more specific to denote a vector because it simplifies where the vector is going. It shows us where the vector is going. So here you can see clearly that this vector is moving from O to P. Let's move down to types. Types of vector. Types of vectors. First one, we have equal vector. Equal vectors. Two vectors, A and B, are said, these two vectors now are said to be equal if they are equal in all respectives. That is, if they are equal in their magnitude, and if they are parallel, the first one, they must be parallel to each other. Second one, they must be equal in magnitude, and both of them will be moving in the same direction. That is, we can say this is a vector A, and we can say this is a vector B. So these two vectors are equal because they are parallel is the first one. The second one is their magnitude are equal. That is, the length of this line and the length of this line is equal. Another one is they must be moving in the same direction. Example, if vector A is parallel to vector B, comma, and magnitude of A is equal to magnitude of B, then we say that vector A is equal to vector B. So, all this explanation of equal vector, if a vector is parallel with another vector, and both of them is moving in the same sense, that is in the same direction, and their magnitude are equal, then we can say that the two vectors are equal. The next one is null, or you can call it zero vector. Null or zero vector is a vector with magnitude 0. The magnitude of a zero vector is 0. It has no particular direction. Let me use this marker as an example. If I place this marker on this board like this, it means that this marker is a zero vector for now. It has no particular direction because I can move it in any place that I want. But standing in one place now is a zero vector. Until I shift it either by right or left or up or down, it now forms a vector. But standing in one place is a zero or null vector. You can call it zero vector or you can call it a null vector. Next one is unit vector. Unit vector. Unit vector is vector with magnitude 1. With magnitude 1. That is, A is a unit vector if magnitude of A is equals to 1. The next one is collinear vector. Collinear vectors. Collinear vectors are vectors that are parallel to one another. Vectors that are parallel to another vector. But remember, it is not that it is parallel that makes it equal. They can be parallel but moving in different what? Direction. So this collinear vector, we can say a collinear vector A moving on this sense. This vector A now is moving in this sense, and we have a vector B moving in this sense. Or vector B can also be moving in the same direction with this, but still their magnitude are not equal. This is an example of collinear vector. We can also have a vector C, even if it is equal, but C is moving in this form. C is moving in this form. You can see is equal to 1 of A, but it's moving in a negative direction. It doesn't mean that A and C are equal, but they are collinear vectors. The next one is coplanar vectors. Coplanar vectors are vectors that lies on the same plane. Let's take this as a plane, and these are vectors. They lies on the same plane. Even let's call this one A, vector B, vector C, vector D. These are coplanar vectors. Coplanar vectors are vectors that lies on the same plane. Next is position. We have position vectors. Position vectors are vectors that omit from an origin. They are vectors that comes out from one particular origin. Let's denote an origin as O. Then all these vectors, let's take these three. All these three vectors are position vectors. Let's say vector A, vector B, and vector C. Three of them are position vectors that omit from origin O. The next one is negative. Negative vectors. The negative vector of a vector A is a vector which had the same magnitude as vector A, but in a different direction. Now, the negative vector of a vector A is a vector which has the same magnitude as vector A, but in a different direction. It is in a different direction. So, remember that example we gave that time about OP, a vector moving from O to P. The negative of this vector can be written as minus OP, or we can say PO moving from P to O, or minus OP. But note that PO, that is a vector moving from P to O, is equal to negative of a vector moving from O to P. And remember, they must have the same magnitude. Their magnitude must be equal. So, the magnitude of a vector moving from P to O is equal to the negative of the magnitude of a vector moving from O to P. So, thank you. I hope you enjoyed the class. See you next time. Bye-bye.
Yeah.